Hello everyone and welcome back. In this video, we're gonna pick up from where we left off last time. Last time we kind of did an informal proof of the product rule, and remember the product rule. What the product rule told us is that a to the m plus n is the same thing as a to the m times a to the n. That's what we learned last time. So what I'd like to do is kind of circle back to that and do one or two examples just to make sure that that's solid before we move on to the quotient rule. So yeah, let's do that. So here let's consider 2 to the 3 plus 5. What would that be? Well, that's the same thing as 2 to the third times 2 to the fifth. And here's where you might need a calculator if you don't know your powers of 2. That's okay. 2 to the third is 2 times 2 times 2, so 2 times 2 is 4. And then once more times 2 we get 8, so that's 8 times. And then 2 to the fifth is 2 times 2 times 2 times 2 times 2, which would be it turns out that's 32. And yeah, I mean, we could continue this. 8 times 32 turns out to be 256. But anyway, that's the main point was to just demonstrate that this and this are the same thing. We could have computed that 2 to the 8th is also 256. And that yeah, but anyway, but let's look at another example. So let's say we have we've got x squared times, or how about, yeah, x squared times x to the third. Yeah, that's fine. Well, using the product rule, we know that when we're in this situation, it's the same thing as being in this situation. So this is where, in this particular instance, we can see that we're in this situation because m here is like 2 and n here is like 3. So all we need to do when we're in this situation is just rewrite it as x. And then remember, on the left-hand side, it's just m plus n. So we add these two together. 2 plus 3 is 5. So that's a little sloppy. That's x to the fifth right there. Awesome. So now that we've done that, why don't we move on to the quotient rule? So the quotient rule, here's what it says. It says that a to the m minus n is equal to a to the m over a to the n. So let's try to summarize what both of these rules are saying really quick. So this says that when you multiply exponents, when you multiply these bases together, where you have the same base a, when you multiply these together, you add the exponent. So multiplying becomes addition in the exponent. Here, dividing a to the m divided by a to the m turns into subtraction. So there's that parallel between multiplication converting into addition and division converting to subtraction. And it's no accident that it works out this way. It's because of how we define exponentiation and everything like that. So instead of proving it this time, why don't we look at some examples? So let's say we had let's say that we have r to the 9th over r to the 3rd. It's using r as a variable. Well, using the property off the bat, we're in the situation on the right-hand side. We have m is 9 and n is 3. So we just need to follow the rule on the left. We just need to do r, it's still the same base, and then it'll be to the m minus n power, or the 9 minus 3. That gives you 6 to the 6th power. So when you have division like this, you subtract, and we get r to the 6th. Let's look at a slightly more complicated example. Let's suppose we have, and I'm actually taking these from the book, by the way, negative 10 x to the 11th, y to the 5th, over negative 2 x to the 4th, y to the 3rd. Well, let's start with the numbers. We have a negative divided by a negative. So what that amounts to be is a positive. So basically these just turn into a positive sign. So I'll just kind of note that by doing this. So 10 divided by 2 is 5. That's the first thing we'll do. The next thing is we'll look at x to the 11th on the top and x to the 4th on the bottom. Well, this is just like this situation over here. We have x to the 11th on top, x to the 4th on the bottom, so we just subtract. So 11 minus 4 is 7. And then similarly with y, we have y to the 5th over y cubed. So we do y to the 5 minus 3, or 5 to the, or sorry, we take y to the 5 minus 3 power, but 5 minus 3 is just 2. So this is how this simplifies. So there's a couple examples of the quotient rule. All right, so that's it for this video. In the next video, what we'll do is we will look at what happens when we have a zero exponent, and we'll kind of give some justification, or at least somewhat of a motivation for why we define the zero exponent the way that we do. But yeah, so that's it for this video. We'll see you in the next one.